All right, now I'm going to do the third page of the 2F diagonal length and angles inside a 3D shape handout. So if I go to the third page, okay, let's do example 20. A regular pyramid has a base with dimensions 8 and 5, and the vertical height here is 10. Find the size of each of the following angles. So that between the edge BE and the base of the pyramid. So the edge BE, okay, so that's this edge right here, and this angle here. So I know the height is 10, and I need this length here, from O to B. So the first thing I did was I said, okay, so we could figure out C to B using Pythagorean Theorem. We know that that's 5 squared and this is 8 squared, so we've got 5 squared plus 8 squared, square root of that, and the length of C to B from C to B is going to be 9.434. So the length from O to B is half of that, which is 4.7. Okay. So now that I know this is 4.7, I've got the opposite side and the adjacent side of the angle I'm trying to find. So I can use tangent. So tangent 10 divided by 4.7, and then I get this value, and I do second tan, and I get the angle here. Okay, next, find the angles between EB and EC. So EB and EC. So if I cut a cross section of this pyramid, I would have BEC. Well, I know, I just found out that this angle here was 64.7, which is what I just did over here, right? So, and if I'm doing a cross section of the pyramid, these two parts are equal. So I know that's 64.7 also, and I need to figure out this angle. So given the triangle, all angles add up to 180. 64.7 plus 64.7 gives me this. Subtract that from 180, and I figure out this angle here at the top is 50.6. That was a much easier problem. Okay, you may want to hit pause to copy this down. Question C, find angle EMO where M is the midpoint of AC. EMO. So I'm going to redraw that here. EMO. And we already know this height here is 10. From M to O, we don't know that length, but we do know that this is 5. So from M to A is 2.5. We need to figure out this distance here. So we know the length of the blue line, so from C to O is the same as from O to B. So the length from C to O is 4.71. We know that's 2.5. We need to find M to O using Pythagorean Theorem. I can do 4.71 squared, which is the hypotenuse of this smaller triangle here of CMO, and we know that's 2.5. So square those and subtract them and take the square root. We end up that MO is 4. Now that I know that's 4, my triangle EMO, and I'm trying to find out this angle right here. So I've got the opposite side, the adjacent side, so I'm going to be using tangent, and then we get my ratio and do second tan inverse, and we get 68.2. You may want to hit pause. Okay, next question. You've got a cuboid with dimensions 6 by 6 by 10.5, and we've got, we want to find the angles, find the length of D to F. So to figure out the length from D to F, this is diagonal through the box, so we're going to do 6 squared plus 6 squared plus 10.5 squared, and we find out that the length of D to F is 13.5. Okay. Question B, find the size of the angle between DF and the base. Okay, so here's the base, right? So we're going to try to find the angle between F, D, and B. So I redrew it over here, F, D, and B. We know this length here is 13.5, and from D to B is the diagonal across the square base here, or rectangular base here. So I needed to find this length here. So what I did is I did 6 squared plus 6 squared, take the square root of that, and I get 8.4. I get this value here. So this value here is 8.485 from there to there. Okay, so now I can figure out my angle between F, D, B with these two things. This is adjacent, that's hypotenuse. I'm going to use cosine, get my fraction, do inverse cos, I get my angle. Okay, then now the last question, find the size of the angle between DF and the face DCG. Where's C? CGH, that's this other side of the box, and DF. So what I did was I know that this diagonal here is 8.485 because I'm trying, so DF and this side here, DCGH, we're going to be using, we're going to try to find the angle between D, H, and F. Okay, we already know, we just found out that from D to B was 8.485, so from H to F is the same value, because it's just parallel above the box. Okay, we know the height of the box. No, we don't know the height of the box, but we do know that this value here is 13.5, and oh, we did know the height of the box. It's 10.5. So let's use a different color. We know that this is 10.5, right? So even if I didn't use that value, I could have used the 10.5. So there's multiple ways to do this. If I'm using the two blue values, then I would use cos. If I use the 8.485, then I could use sine or cosine to find the angle. You may want to hit pause to think about this some more. Okay, question, second to last page, or last page. Okay, so for each figure, find the angle between the given segment and the base. So KO is right there. So to figure out this angle between KOL, I know that the height is 3, the base here is 4, so I don't need to do Pythagorean Theorem at all. Opposite side is 3, adjacent is 4. I'm going to use tangent since it's opposite over adjacent, and then I do inverse tan of 0.75, and I get this angle. For II, we're trying to find the angle between JX, J to X, and the base. So we've got triangle JXM, JXM. We know this is a right angle. And I need the length. Well, we know the height. We know that JM is 3, right? And from there to there is 3, right? And I need this length from M to X. So from M to X, I need to figure that out first. So, and from the triangle here, I know that from M to N to X, there's a right triangle here. So from m to n to x, I redrew over here, m to n to x. We know that this here is 4, and this cuts it in half. That's 2. So if that's 4 and that's 2, I can figure out my diagonal pink line. So 4 squared plus 2 squared gives me 20, square root of that, and the length of this pink line is 4.47. Now that I know the length of the pink line, I can find this angle, opposite over adjacent. I'm going to use tangent, set up the ratio, inverse tangent, and I get 33.9. Okay, last part of this question. Find the angle between ky and the base. So where's k and y? So the distance, we don't know the length from k to y, but we do know that from and right above k is L, right? So ky to L. We need this angle. So we know that's 3. And the other thing that's going to help us with this is we know that the length from L to y is going to be the same as m to x. And you might say, why would I know this? Because from L to m is 4, from m to y is 2. I'm going to be doing the same process that I did with m to x, and I'm going to know that those are the same values. So now that I know that that's 4.47, I'm going to have the same answer as I did with part II. You may want to hit pause and think about that for a minute. Okay, now last part. We've got this cone here, and the height of the cone is 5, the radius of the cone is 2, and it's the angle between A, O, and C is 120. So what I'm going to do is use that information, and we want to find the angle between AF and the base here. So A to F and O is the angle we're trying to figure out at angle A. So we know the height here is 5 from A to F to O, and we know that the radius of the triangle here is from A to O. We know that radius is 2. So given that information, to solve the angle between AF and the base, if I know that's 5 and that's 2, I can figure out my angle using opposite over adjacent, 5 over 2, inverse tangent, we get 68.2. Question B, find the angle between the slant height of the heap and the base. So I need to figure out the slant height from A to F. So the slant height is, we're just figuring out the slant height. Okay, so using Pythagorean Theorem, we're going to find out this value here. So 2 squared plus 5 squared is going to give me AF squared. So 2 squared plus 5 squared is going to give me 29. Square root of that. The length of A to F. The length of A to F is 5.39. And I'm going to use this value here in part C. So we want to find the angle between AF and CF. So AF and CF. So this is the triangle that I'm going to be using. AF we know is 5.39. AC we know is 5.39. And I need to figure out the angle between, or the side AC. So the first thing I did is I look at the base, and we know from this information here that the AOC, this angle right there, is 120. I redrew the triangle here of the base. And the radius is 2, so I know that's 2 and that's 2. And we're trying to figure out this length here. So I can use the law of cosine, so I could say the length of AC squared is equal to 2 squared plus 2 squared minus 2 times these two sides cosine of 120. cosine of 120 is negative 0.5. So 8 times negative 0.5 gives me 4. So 4 plus 4 plus 4 gives me 12. So AC squared is 12. Square root of that gives me 3.46. So now I know the length from A to C is 3.46. Okay, using that information, I went over here, and now I've got this triangle, and I know 3 sides of it. So if I'm trying to find this angle, once again, use law of cosine. So 5.3 squared plus 5.3 squared. These are the angles on either side. These are the sides on either side of the angle. Minus 3.46 squared divided by 2 times the sides on either side of the angle. And then I get, this simplifies to 29 plus 29 minus 12 divided by 58. And I get this ratio and this decimal, and then I do inverse cosine and I get this value. You may want to hit pause to check your work.